This is linear algebra 5.2 characteristic equation. Previous video, we're gonna study what is eigenvalue, what is eigenvector. So this section, how gonna find eigenvalue when you give the metric. So let's start with what is characteristic equation, guys. So before we discuss about the characteristic equation, let's quick go over what you learned so far. Eigenvalue vector x gonna be correspond to the eigenvalue number. This eigenvalue vector eigenvalue gonna be satisfying this equation. A metric A times x vector is lambda x. This one satisfying this equation, and here is very important idea is non-zero vector we call eigenvectors. Okay, when you satisfying this metric equation, then we're gonna say this one lambda gonna be eigenvalue, right? Then another way write the metric equation is A minus lambda identity. I gonna be identity metric, guys. Then satisfying this one, guys. This one is what? This is we call homogeneous equation, right? Homogeneous, this one is constant vector is 0. Another way you have non-zero vector is you're gonna say eigenvalue vector x gonna be non-zero vector is non-trivial solution of this metric equation, guys. Very clearly understand the non-trivial solution. Then invertible theorem say this is non-trivial solution is this one is not invertible, which means this metric doesn't have inverse metric. So this one is not invertible, meaning is determinant A minus lambda identity metric is gonna be 0. So all statement is the same. Determinant A, metric A minus lambda is 0, meaning is lambda gonna be eigenvalues. That's we're gonna use to find an eigenvalue here, guys. So another terminology here, you see, determinant A minus lambda I equals 0, we call characteristic equation. Only this term we call characteristic polynomial. So I give the example to explain what is characteristic equation, what is characteristic polynomial. But main idea is, guys, how can find eigenvalue? We're gonna calculate the determinant metric A minus lambda I. Let's see the example next page. So characteristic equation is another way I'm gonna rewrite this idea is right here. Eigenvalue is gonna be lambda, then lambda is satisfied this determinant we call characteristic equation. When you solve this characteristic equation, we can find the lambda. Okay, let's talking about characteristic equation definition first. What is characteristic polynomial? So let's do this one, guys. Look at this. Characteristic equation meaning is determinant A minus lambda I equals 0. That's we call characteristic equation. So what is A minus lambda I? So you have here A gonna be 2, 1, negative 1, 4 minus lambda. We don't know the lambda yet, guys. 1, 0, 0, 1. So put together, guys, here. 2 minus 2, 1, negative 1, 4 minus lambda 0, 0, lambda. Another way, you do the metric operation 2 minus lambda 1, negative 1, 4 minus lambda. That's the metric of A minus lambda I. So what is characteristic equation? You're gonna find determinant of this metric. That's gonna be 2 minus lambda 1, negative 1, 4 minus lambda. How can find it? This one, guys. This one is determinant of 2 by 2 metric. This one, 2 minus lambda, 4 minus lambda, minus 1 times 1. So you have here expanded A minus 2 lambda minus 4 lambda plus lambda square minus plus 1. This one is lambda square minus 6 lambda plus 9 equals 0. That's we call characteristic equation. Guys, remember definition of equation, this is 0. Or, so you have to remember this one. Lambda square minus 6 lambda plus 9. That's the determinant. A minus lambda I. This one is characteristic polynomial. Guys, make sense definition? So let's we're gonna be working on find an eigenvalue, guys. Okay, they said find eigenvalue of metric A. So we have to do this, meaning is, guys, we're gonna find lambda such that determine characteristic equation A minus lambda I equals 0. That's we're gonna find the lambda, right? So find this one. Let's say A minus lambda I. So how can find this metric quickly is diagonal metric gonna be 2 minus lambda 3, 3 minus 6 minus lambda. That's the metric of A minus lambda I. Determinant A minus lambda I, we're going to find characteristic polynomial 2 minus lambda negative 6 minus lambda minus 3 times 3 equals 0. That's the characteristic equation, guys. So let's calculate this one together. So how can calculate it? Expand it. So this one is negative 12 plus, now minus, so what I do, negative 2 lambda plus 6 lambda plus lambda square minus 9 equals 0. So what do you have? Lambda square plus 4 lambda minus 21 equals 0. So you're going to see this one is what? Quadratic equation, right? Quadratic equation. So how can you solve it? Factor it. Lambda plus 7, lambda minus 3 equals 0. So you find the eigenvalue here. Lambda equals negative 7, lambda equals 3. That you find there. So another way you're going to find the lambda, you can find an eigenvector, another eigenvector. We are not going that far, guys. That's we find the eigenvalue, okay? Let's practice finding eigenvalue of 3 by 3 matrix. If you paused this video, do yourself, compare your answer later. So first, what you have to find the characteristic equation, right? A minus lambda I equals 0. You're gonna solve this equation. First, you have to find A minus lambda I. So this metric gonna be 3 minus lambda 0, 0, negative 1, 1 minus lambda 0, 2, 1, negative 2 minus lambda. Okay, second, so how can calculate determinant A minus lambda I? You're gonna find the row or column with most zeros. I'm gonna pick the first one. Here is this one. You're gonna expand the first row, 3 minus lambda. Find determinant to this one. That's the 2 by 2 metric, right? So this one is times here, 1 minus lambda times negative 2 minus lambda minus 1 times 0 is 0. That's it. That's you find determinant A minus lambda I. Or you're going to remember the theorem. Triangular metric is diagonal, above diagonal, below the diagonal, all those 0. Determinant of this metric gonna be, you can see right here, entry is diagonal. 3 minus lambda, 1 minus lambda, negative 2 minus lambda equals 0. That's another way you find this determinant. Okay, how can solve this one, guys? This one is 3 minus lambda, 1 minus lambda, negative 2 minus lambda equals 0. They already factor 4. So you're going to solve this equation. This is 0, this is 0, this is 0. So you have lambda equals 3, lambda equals 1, lambda equals negative 2. That you find the 3 eigenvalue here. Okay. Next one is bigger matrix. How can find eigenvalue of 4 by 4 matrix? Have idea, guys? Can you see this matrix? See, this is diagonal. Below the diagonal, that's gonna be 0. We call triangular matrix. Okay, that's good news, right? So let's find determinant a minus lambda I. We want to find the characteristic polynomial characteristic equation first. Let's calculate L minus lambda I first. This is gonna be 5 minus lambda, negative 2, 6, negative 1, 0, 3 minus lambda, negative 8, 0, 0, 0, 5 minus lambda, 4, 0, 0, 0, 1 minus lambda. That's the metric of A minus lambda I. This triangular metric, how can find the determinant A minus lambda I? You're gonna product of entries in diagonal, which meaning is 5 minus lambda, 3 minus lambda, 5 minus lambda, 1 minus lambda equals 0. So what do you see, guys? Each factor gonna be 0, right? This one 0, this one 0, this one 0, this one 0. Can you see that lambda equal 5, lambda equal 3, lambda equal 5, lambda equal 1. How many 5 here? 2, right? Lambda equal 5. If you remember algebra class, this we call multiplicity is 2. How many? 3. Lambda equals 3. That's one answer. Multiplicity is 1. Last one is lambda equals 1. Multiplicity is 1. Another thing you might notice, guys, see that right here is eigenvalue is here right there. 5, 3, 5, 1. So go back to matrix A. Here is diagonal, entry diagonal 5, 3, 5, 1. So when you have a triangular matrix, entry of diagonal is gonna be exactly same as eigenvalue.